Good morning, good afternoon, good evening, mammals. This video is being posted on Friday, April the 24th, and it goes along with the problem set that I posted today. If you did a really good job at watching the notes, you may not need to watch this video and you can just skip it, but I'm going to walk through two problems and show you what slide that you need from the notes that's going to be super helpful when you do this. So this might be an optional video for you if you can do it without me showing you how, but I would have done two examples in class, so I'm going to do two examples here. The main slide that you need to get from the notes is this one. So I'll pause for a second if you want to take a screenshot of it. Okay, it's going to be super handy because it summarizes what is true for the different signs, either positive or negative for delta H, delta S, and then gives you the different combinations of delta H and delta S to tell you what's going to be true for delta G. And when I do the two examples, I'll show you how to use this to answer these problems. Within each of these problems, what I give you is up here at the top. So all the numbers that you need comes from this. I give you the enthalpy of the reactants, the products, the peak, and a delta S value. So I tell you three things about enthalpy, and then I just give you the overall change in delta S. If we were doing this in class, you would have to sketch it. It might be useful to think about what that sketch would look like, but on a Google Docs I won't ask you to do it. What you will have to do is you will have to tell me whether it is endothermic or exothermic, whether it is more or less random. You'll have to do two subtraction problems, one to get delta H and one to get the activation energy. And then you have two multiple choices here asking you what is true about the favorability of delta H and delta S and what's going to be true for delta G. So I'll make up two problems where I just make up these versions of numbers and answer these same questions regarding that. And I'm going to scroll down so I can look at this because this is the info that you should be looking at while you do these problems. So let's say I have an H of reactants of 20 and an H of products of 100 and a peak value of 110 and a delta S of negative 30. So I've given you all the info that I would have given to you in one of these problems. I don't ask you to sketch it, but like I said, it's kind of helpful to think about what that sketch would look like. I would be going from reactants, 20, to products, 100, with a peak value in the middle of 110. So my graph would look something like this. And that graph is an endothermic graph. So my first question would be endothermic because this graph is running uphill. It has to absorb energy. I'm going to look at my delta S to tell me if it is more or less random. I have a negative delta S, so that means it is less random. Positive delta S's would be more. Now I have some subtraction problems to do. My delta H is products minus reactants. So 100 minus 20, I get 80. And my activation energy is the peak. It's the difference from the start to this highest value here. It's peak of 110 minus 20. That equals 90. Now my two multiple choices are going to be where this chart comes especially in handy. So I can find the row that matches up with the numbers that I've been given. I have a positive delta H and I have a negative delta S. So I'm going to find the row where that is true, and it's this bottom row. So I'm going to be getting my answers for the multiple choices from this. It tells me that positive delta H's are unfavorable and negative delta S's are unfavorable. So I'm going to choose the first multiple choice that says that both of those are unfavorable. And then the second one asks me about delta G. This tells me that the delta G is going to be always positive. So I'm going to choose the option that says delta G is positive at all temps because it's always positive. Okay. I'm going to do one other example, and I'm going to do this example so that it winds up landing on one of these where you have to actually solve for the temperature, because those can be a bit trickier. You have to do a little bit of math. So bear with me while I erase these numbers. And make up a new set. So let's have H of reactants being 150, H of products being 20, H peak being 170, and delta S being negative 10. I'm going to go through the same scenario here. If I thought about what this graph would look like, I would be starting at 150, going up to 170 at my peak, and then going down to 20. So I would have a graph that looks like this, and this is an exothermic graph because this reaction is losing energy. My delta S is still negative, so it is still a reaction that produces less randomness. My two subtraction problems, delta H is going to be 20 minus 150, so that's negative 130. And my EA is going to be 170 minus 150, that's going to be 20. I consult my chart to help me with the favorabilities. I find the row where I have a negative delta H and a negative delta S. That's this row. It tells me that delta H is favorable, but delta S is unfavorable. And the last option tells me that delta G is going to be negative, not always, but only at lower temperatures. If you remember from the notes video, I solved for temperature when delta G is going to be 0. That's our break point between spontaneous and working and not. And that is going to be when delta H is divided by delta S. So I need to say delta G is negative. This tells me at lower temperatures, so I'm going to choose negative below. And then I'm going to do this math where I divide my delta H by my delta S. Negative 130 divided by negative 10, that's 13. So delta G is negative below 13 degrees. So this is how to use this chart to answer these problems. I think you will end up with one from each row here with these 4 problems, so it covers all the possibilities. If you need any help, you can always reach out to me on Remind, email, or with a comment on Google Classroom, and I'll try and get back to you as quick as I can. As always, take care of yourself and others, practice good hygiene, and I'll see you on the flip side, which is, I guess, now next year.